that n is small equal to 2000. So each field I is described by a distinct point x, I, y, I in the 2D plane with 0 small equal to xi and yi small equal to 1000. The cost of building a water pipe between two fields I and j is equal to the square Euclidean distance between them. So just a distance form, distance formula but squared. So Farmer John would like to build a minimum cost system of pipe. So you notice the keyword here, minimum. So that probably gives like a hint away about what to do. So that all of his fields are linked together, so that watering any field can follow a sequence of pipes to reach any other field. Unfortunately, the contractor who was helping FJ install his irrigation system refused to install any pipe unless its cost, including this length, is at least C. So please help FJ compute the minimum amount he will need to pay to connect all his fields with a network of pipes. So yeah, that is the whole problem. So you can notice that like this at the beginning, this may seem like a big math problem, since we need to connect every single we need to connect dots such that like any dot can reach any other dot, and we also see that the length is at least C. So yes, how do we do this? Well, first of all, we notice that there's 2000, which means that we could just like there's only n squared edges, remember? So there's only 4 million edges at max, and 4 million is not that much. So we can use any of the MST algorithms on this problem because they definitely run within time of 4 million edges. It is 2000 nodes and then 4 million edges. So yeah, Prim definitely runs faster for this one because there's only 2000 nodes to process for Prim, while Cruise has to process all 4 million edges. But so yeah, well, like I'm pretty sure like even like 10 to the 8, like 100 million will work. So yeah, 4 million is like not that much. So there are 3 fields. Let's look at the sample. So there are 3 fields at location 0, 2, 5, 0, and 4, 3. So the contractor will only install pipes that cost at least 11. So the minimum cost of a network pipes connecting the fields or negative ones, no such network can be built. So like, what in case? Well, like imagine like you have 3 dots, 0, 0, 0, 1, and 1, 0, and the distance between each of these is 1. If you square them, they're still 1. Maybe not the 1, 0 to the 0, 1 is I think like square root of 2, right? The distance is square root of 2, and if you square it, it's just like, wait, yeah, I think it's what, yeah, that's the distance is between 1, 0 and 0, 1 is 2, the cost. So we only install like pipes of at least cost like let's just say 100. So we can't install anything. So the graph will remain disconnected in 3 components, namely the 3 coordinates, because since none of them are connected. So in that case, we just print -1. But in this one, we can. So we cannot build one between 4, 3, and 5, 0 since the cost is at only 10. He only builds a pipe between 0, 2, 5, 0 at cost 29, and a pipe between 0, 2, and 4, 3 at cost 17. So, like, in order to approach this problem, you can see that it's minimum cost of system such that all of them are connected, which is the definition of a minimum spanning tree. So that pretty much gives it away. And on top of that, you see this 2000, which means that you go n squared, generate all the edges between every single pair of coordinates, and it will still run in time. And that is indeed the intended solution. And yeah, you can see that he only used 2 edges here, which gives the final fact away that it is a minimum spanning tree. So all we have to do is generate the edges and run any of the minimum spanning tree algorithms, and we will get our MST. And we just print its cost in the end. And if we cannot do so, we just print -1. Okay, since there's like a decent amount of time left, I'll be coding this like problem live for a better like idea. Okay, I'll share it to like my IDE. Okay. So yeah. We're doing okay. Okay, I'll be like coding this with like Kruskal's algorithm. since I feel like that one probably needs more code explanation, since prims is pretty much similar to Dijkstra's. So yeah, I'll be coding Cruise codes for this one. So for this problem, like we need to generate all the edges, right? So first of all, like we have to read in N and in C. So I'll just like do the normal input. So yeah, I just read it in N and C, and now we just read in the coordinates of the points. We could create like I guess like a class pair. Okay, so we could create like a pair array, call it nodes. And we could just like for nodes at I, let's create a new pair. Okay, so that handles all the input. So now what we want to do is that we want to generate all the edges. Generate all the edges and push them into like MST if weight is actually push them into the edge list if weight is greater than C. Okay. So now we just how do we generate them? We just loop through every pair of nodes and we just try to like just loop through all possible pairs. Okay, so what is the weight? So the weight is equal to. Is there a square method? Okay, I'll just like create one. So it's a distance formula squared. So it's like basically like node I at x dot x minus node at j dot x, and we want to square that, and then we just add it to the square of the y's. Yeah, so normally for the distance formula you just take like square root, but the problem like got rid of it for us since they're nice, and so we don't have to deal with doubles. And so like that's the weight, right? So if weight is greater than or equal to C, we just add them to edges. So edges dot. Yeah, I need to create a new array list of. I'm pretty sure it's a pair, right? Yeah. yeah, it's just a pair of edges. Oh, we also need its weight. So yeah, it looks like we would create a new class called edge. Does everybody still follow along? Okay. So we have int v u, which is 2 nodes, and then weight. So edges. So if it's like good, we just push it back. Add a new edge consisting of weight, and then oh yeah, we should probably switch the order here. And then I and j, which is according to the points. So yeah, that creates all the edges for this graph. And now all we have to do is run Kruskal's algorithm. Okay, so we need to like sort all the edges. So collections.sort edges new comparator. We just return edge. I'll just call this like edge 1, edge 2. Okay, so we return edge 1 dot weight smaller than edge 2 dot weight. Actually, okay, yeah, so that's right. So now after we sort it, right, we should sort it by its weight. Okay, I'll just replace with list.sort. Okay. So now we need a DSU. So I guess here's a DSU code that is previously like I already have. So yeah, all we have to do is like paste it inside here. Okay, so I guess to explain the code, why is it? Oh yeah, the duplicate class. Oh, change this to like DSU1. Okay. Okay, so class DSU. So it's the number of nodes, like the separate disjoint sets we have at the beginning, counts the number of connected components we have. At the beginning, it's also n. Parent denotes the representative of the group. The rank denotes the number of the like basically the size of the group, and size denotes the size. The rank is actually different, but rank is like the height of the group, and the size is the size of the actual group. So we have public DSU. We assign n to be n. We assign count to be n, so there's n disjoint sets at the beginning, and we basically assign all of them a new array. For each of them, we like assign the current parent of itself, the representative to be itself. The size is 1, it includes itself. So find, I guess like these two are like the main key algorithms like for DSU. So find does that finds a representative of this group. So if its currently representative is itself, that means that it is the head of the group, which is the parent itself. If not, we find the representative of its parent. So which is a recursive method to do that. And this is actually like using 2 heuristics. I won't be explaining it here because it'll take way too long to explain. But just know that like this implementation of DSU is it's like basically linear. It's actually like pretty sure it's like it was a function called like it's too complicated to explain. So yeah, just it's basically linear, but a little bit like slightly worse than linear. with the two heuristics. So you can read this up on like DXOR Geeks. So union, it unions two node, it finds them, and if they're represented the same, they're in the same group, we return false because they cannot be union anymore. Otherwise, we want to concatenate the smaller one to the bigger one such that its height is small. When its height is small, the find can find it faster. So we just switch them if their rank are different, and we assign B, which is a smaller one, to A. The represented, we just concatenate them. So if rank A equals to rank B, we add one to rank A, since the rank of A increased by one. The basically like the levels. Otherwise, we add the size of the B set to the size of A because the two group merged, and then we subtract one from count because two group merged into one. And return true since we did concatenate. Size basically finds the size of this entire group. It finds it using its representative because only the size of the representatives updated, because which is denoted by P, which is another like word for parent. So we cannot update everything inside the group because that'll take way too long. So we just use size. So yeah, that is the whole entire DSU code. And now what I want to do is like create a new DSU of size m. Okay, and now we just run the algorithm. So yeah, so currently the cost is 0 since we have not taken. It's number of like nodes taken, and so for edge of edges. So weight I'm just doing this so that because the variable is kind of long when we like use edge dot u will be or w. So if we successfully union v, yeah, if we successfully DSU dot union u and v, then we just add the cost w. Since we just concatenated them, right? We just added the two groups together, like we chained them together, so that we're using this edge. So we add w to the cost. We add one to taken, because we taken one more edge, and yeah, and if in the end the number of things taken is equal to n minus 1, which is forming or successfully formed the MST, we just break out. That is the entire code. So why is this error? Oh, this is Java. So long cost equals 0. Okay, so if it's impossible to form MST, then the number of edges will be less than or equal to n minus 1. No, less than n minus 1. Yeah, if it's n minus 1, then it's right. So if the number of taken edges is less than n minus 1, print -1. Otherwise, we print its cost. That is entire code. So this is the entire, like, yeah, believe it or not, this is the entire MST code. It's just the one for loop, and one if statement. So I believe this will work, or maybe there's like I made some mistake somewhere. So okay, I'll be running this code now. Oh. And you give -1. So I probably made a bug somewhere. Did I not union them correctly? So DSU union UV. Okay, I guess I'll try to quickly fix this. So let's see what happened here. Okay, so cost of 7. Wait, why is the weight is 17 and it's between 1, 3. 0, 2, and somehow somehow the sword didn't go correctly because the first edge should not be having weight 17. That's not the cheapest. Okay, yeah, I'll be like debugging this part. The weight is 29 between 1 and 2. Yeah, so that is right. Oh wait, no, this is right. This is right. Okay, it looks like yeah, it just looks like something went wrong. So it somehow didn't union correctly, I think. Okay. Um. Okay. So it looks like the parent did not get updated correctly. Parent I equal to I. So this should be right. Wait, did my DSU not get like created properly? Yeah, why is the parent of everything 1? Okay. Okay, so it looks like that's the bug. Okay, so it's like right here. Yeah, somehow the DSU is like not working correctly. It's like creating ones for all the nodes. Well, this is like implementation I converted to Java from C++, so I don't know if it's like fully correct. Or yeah, I don't really know how like the parents got converted to all ones afterwards. Okay, any of you guys like find like why this is like being assigned to like 1? Like this array, the array P. Everything is getting
Wait.
assigned to 1 for some reason.
When are you saying that they're all one? Because at the end they are all one, right?
Yeah, but like I'm debugging right here, right? Like it shouldn't be all ones. I guess this is
Oh.
like some bug or something because this like perfectly worked in C++. So I think this is like maybe language specific because I created this DSU, and then always parent gets assigned to 1 after.
So this is just right after you made the
Yeah,
DSU?
right after I made it, all the parent got assigned back to 1 again. They should be like 1, 2, 3, 4 for some reason. Yeah, this shouldn't happen because I didn't touch the DSU at all, so it should like remain like all its parents should remain like.
Wait,
Right.
can you go back to the DSU code?
Yeah.
Oh, it's cause you set P, rank, and size all to the same array.
Oh yeah, that's it. Yeah.
Oh, right. Oh yeah. Yeah, I haven't used Java in a while, so I'm kind of rusty with this. So now this should work. Yeah, 46. That is the correct one. I guess yeah. I'll probably submit it to Usico just to see like the correctness of the solution. Okay. All right, I shouldn't use system.print. I remember this is not the newer Usico. This is the older one. I'll quickly change the print writer. Okay, submit solution. So this should work. So yeah. Oh. Okay, I guess it timed out on 1. So yeah, I guess this is why like people suggest to use like C++ for Usico, since everything was like under 200 for that one. So yeah, Prim definitely like works faster for this one since there's less nodes. Like there's like 2,000 nodes. But yeah, even with Crucible, I could see you could get like 9 out of 10 cases. So if you convert this to like a faster language like C or C++, you could get all 10 cases. So yeah, I guess Oh yeah, also for the older problems, the time limit is 2 seconds, not 4. So Usico was kind of mean back in the day to Java people, since even C++, C, Python, Java all had 2 seconds for the limits. So yeah, Java had a huge disadvantage for this. But either way, even if you use Crucible, which is a slower one for this one, as I said, and use a slower language, you could still get 9 out of 10 cases. So yeah, I guess that is all for this meeting. And if you guys have any questions, you could like say them